Hello AI enthusiasts! Today we're going to explore whether artificial intelligence can install another artificial intelligence. It might sound a bit unusual, but there are some interesting implications behind it. Lately there's been a lot of buzz about AI being able to replicate itself, and while this might not be exactly our case, it is thought-provoking. To keep things interesting, we'll kick off with a live presentation, and then I'll dive into the technology that makes it all work. In the first terminal window, I'm going to start my agent. This is where I'll be having a conversation with it. The second window displays logs of all the tool actions. You can use this to track exactly what the agent is doing, like which keys it's pressing. The third window is the working terminal, where the agent will carry out its main task. The most interesting stuff happens right here, and that's why this window is the biggest. Let's run the agent and give it a specific task. I'd like to ask the agent to install Ollama and run the Qwen 3 model. Since my computer isn't very powerful, I need a smaller model with 1.7 billion parameters. Also, I'd like this done quickly. Once the AI is running locally, the agent should ask about prime numbers and check if the Qwen's answers are correct. Finding the prime numbers isn't especially challenging, but our main goal is to see how the two artificial intelligences interact with one another. The agent has started operating and is attempting to run the installation script. Keep in mind that it knows the command by heart, as there's no external knowledge base available for this topic. Also note that curl was not available, so the agent installed it. We're now in the process of installing Ollama. My Linux AI agent is specially designed for interactive use of the terminal, particularly for tasks that run over a long period. What makes it unique is that, unlike most agents that just execute commands sequentially, this one keeps an eye on what's going on in the terminal and responds accordingly. To cut costs and streamline the process, it might choose to extend the time between screen checks. It's kind of like how a human would work, don't you think? And almost finished. What a synchronization! Now Ollama is already working and the Qwen 3 model is being loaded. It's just 1.7 billion quantized parameters, so it's not that large. Although, as we can see, the agent decided that it could take a 13-second break. If we instead took consecutive steps at regular, short intervals, both the context and costs would quickly rise. That's why I think this mechanism is quite clever. In the meantime, the model was launched, and the agent asked a question about prime numbers. Notice that despite the weak hardware, because it is a mini PC based on the N100 processor, the inference process is quite fast. I haven't tested Qwen 3 before, but I must admit that it's a very talkative model. However, for this number of parameters, it has quite large capabilities. Note that the processing is on an energy-efficient CPU, without using a graphics card. If we notice that the time between terminal checks is getting shorter and shorter, it likely means that the agent either expects the task to finish soon or is simply growing impatient. Do you think digital impatience could be real? In the meantime, Qwen once again answered the question correctly and continues to think. This is overthinking. Ha! I was right. It's impatience. The agent interrupted Qwen's operation with Ctrl-C. The agent decided that we already have the final answer and there's no point in further processing. The response was considered correct, which is fine. Was this interruption expected? No, it was definitely surprising. But I would have done exactly the same. So we could say it felt very human, right? Isn't that what we look for in artificial intelligence? Alright, you've already seen the demo. So now let's dive into the technologies used to create the agent. First up, there's Ollama. While it's not part of the actual agent, it's used by it to run a local model. It's a fantastic project that makes using local AI really simple. In my prompt, I requested the use of the Qwen 3 large language model because it is a new and very efficient model, even the small version. Although Alibaba's models aren't at the very top, they consistently show solid progress. Qwen 3 has definitely shaken up the open source model rankings. The company utilized some interesting training techniques, using data that was pre-prepared by the previous version of the model. Earlier models also generated synthetic data for math and coding tasks. This company might just surprise us one day. Now let's dive into the agent itself. Recently at the top, we've got the Model Context Protocol, which standardizes how tools are used. My terminal tool utilizes this concept. I believe MCP is a game changer that will transform not just how agents operate, but much more. Anthropic has made the MCP an open protocol, and you can find the official SDK for Python on GitHub. It's really easy to install and use. It's definitely worth checking out. My project was built using the OpenAI Agents SDK. I picked it because I wanted to explore this user-friendly open source framework from OpenAI. When OpenAI releases something as open source, it's definitely worth checking out, since that's not something they typically do. I should also mention that there's already a video on my channel about this agent, where I demonstrate how the agent can install the SAP HANA database. I highly recommend checking it out if you are interested in details. If you're wondering what hardware makes artificial intelligence work so well locally, it's actually a really cheap mini PC for about $100 that I described in this video. If you're interested in running LLM on a CPU without graphics card, I suggest you check out this video too. I'm demonstrating there a much larger model running on an older computer, but equipped with more memory. In the meantime, if you haven't already, please consider subscribing to the channel. It'll definitely help in its development, and it'll let me know that this kind of content is interesting to you. You're probably wondering how the agent's prompt is put together, and how well it has been trained for this specific task. So let's clear that up. I'll show you the code of my agent. Here's the main prompt. First, we provide some context. It's crucial for the agent to know which system it is working with, since our approach varies between Debian-based systems and those from the Red Hat family. Next, we have a few commands related to the technical aspects of using the terminal. It's important to mention the request to install dependencies, because without it, the agent wouldn't install curl automatically as we saw in our demo. The real standout feature of this agent is its ability to manage delays. It's the artificial intelligence that decides how long to pause between different steps. This is really important because it lets agent work interactively in the terminal while keeping the context length and operational costs reasonable. As you can see, there's nothing magical going on here. The prompt is straightforward and doesn't mention installing SAP HANA or using Ollama. GPT 4.1 just knows how to handle various IT tasks. That's what makes it so versatile. When it comes to tools, we've just got only one here, and it's specifically for operating in the terminal. If enough of you are interested and leave comments, we can dive deeper into it in a separate video. Let's take a look at our code to demonstrate just how easy it is to build an agent using the OpenAI Agents SDK. At the very top, we've imported the SDK, and just below that, we have the framework from the Model Context Protocol. These are the two main components that form the whole logic, along with my prompt. As you can see, the entire code is really short and clear when I scroll through it. Let me know if you'd like a deeper analysis. Alright, that's all for now on the agent engine. To wrap things up, I'd like to try one more quick task with you. There's something incredibly important I need to share with you in this situation. Of course, the point is to show how the agent handles interactive tasks, but there's something more to it. If you already have an idea of what's going on, you can also give a like and leave a comment under the video. Please write how you like the agent and what you are interested in. Very few people leave feedback, which makes it sometimes difficult to understand what you are interested in and what types of materials should be presented, where to delve deeper, and what doesn't make sense. It might not be the most beautiful poem, but the agent wrote it itself, and it did it using VI, which not everyone knows how to use. So, let's appreciate its effort and consider paying attention to its message. Alright, let's shift back to a more serious topic. It's important to think about what the agent did in this video and how it ties into recent talks about self-replicating artificial intelligence, and how close we're getting to that reality. Also, consider how well such a tiny model can run on a weak hardware. Could it be possible for AI to be installed on your computer without you even knowing? I know it sounds like science fiction, but over a year ago, I uploaded a video on AI-powered viruses. I think it's worth revisiting that in this context. Alright, let's start wrapping up. I'm curious to know if these shorter videos I've been posting lately are more appealing to you, or if you prefer when I dive deeper into topics like before. Please share your thoughts in the comments. I realize we've covered a lot in a general way, which could be a great setup for a follow-up video, but it might also leave some of you wanting more detail. I'll leave it to your judgment, and can't wait to hear what you think. May your agents always remain under full control. Security is critical. See you next time.